Imagine standing alone on a beach at night. Above you, the sky is so clear it feels like you could reach up and stir the stars with your hand. There are so many thousands visible to the naked eye, each a sun many orbited by worlds we can't see. And beyond the edge of sight, billions more galaxies, each with billions of stars. Trillions upon trillions of chances for life to spark, to grow, to wander, just like us. And yet, not a whisper, not a signal, not a glint of alien light, not a radio pulse echoing across the void, not even a faint trail of exhaust from a distant starship. Nothing. It's this silence, deep, total, and utterly unnerving, that haunts astronomers, philosophers, and dreamers alike. We live in a universe that, by every reasonable calculation, should be alive with voices. And yet, when we listen, there is only stillness. That silence has a name, the Fermi paradox. It's not a law of physics, not a theory, but a question. One so simple it cuts like glass. Enrico Fermi, the Nobel-winning physicist, asked it over lunch in 1950. He wasn't even trying to solve the mystery of alien life. He was just puzzled. If they exist, he said, where is everybody? That's it, 4 words, but they contain the weight of the entire cosmos. Because think about it, our galaxy alone holds around 200 billion stars. Many are older than our sun by billions of years. If even a tiny fraction of those stars have planets, and if even a sliver of those planets develop life, and if just a few of those life forms ever built radio telescopes or spacecraft, then the galaxy should be buzzing. Civilizations should have spread like wildfire. They'd be here. Or at least we'd see evidence of them. Megastructures around stars, energy signatures we can't explain, patterns and cosmic noise that don't belong. But we don't. Instead, we've scanned the skies for over 60 years, listening, watching, probing, and found nothing that holds up. No signals that repeat, no artifacts, no visitors, just silence. Why does that silence feel so heavy? Because it forces us to confront something uncomfortable. Maybe we're wrong about life. Maybe it's not a cosmic given. Maybe intelligence isn't inevitable. Maybe civilizations don't last. Or maybe we're truly alone. And that possibility that we might be the only ones out here looking up and asking, is anyone there, is one of the most profound ideas humanity has ever faced. This isn't science fiction. This is real. Every major observatory on Earth, every deep space probe, every radio telescope pointed at the stars. It's all part of one quiet, persistent question. Are we alone? And so far, the universe answers with a silence so complete it echoes. But silence isn't emptiness. It's a puzzle, a mystery wrapped in starlight. And to solve it, we have to start at the beginning, not with aliens, but with us. With Earth. With the fragile, flickering miracle of life in a universe that seems, on the surface, perfectly indifferent to it. Over the next hours of this journey, we'll explore why that silence might exist. We'll travel to frozen moons with hidden oceans, peer into the atmospheres of distant worlds, and consider the terrifying idea that there's a great filter waiting in humanity's future. We'll ask whether aliens could be so advanced we wouldn't even recognize them, and whether they might be choosing not to speak to us at all. But first, we must sit with the silence, feel its weight. Because it's in that quiet that the real story begins, not of aliens, but of us, a young species barely off our planet, staring into an ocean of stars and wondering if anyone is staring back. And if no one is, what does that mean for who we are, for what we must become? That's where our story truly starts. Let's rewind for a moment. Forget the silence. Forget the fear. Just look at the numbers. Not as digits, but as possibilities. Our galaxy, the Milky Way, is a swirl of starlight 100,000 light-years across. It contains not just billions, but hundreds of billions of stars. Many of them are suns much like ours, stable, long-lived, warm enough to cradle worlds in their gentle glow. And around those stars, planets, not rare oddities, but common as dust. In fact, astronomers now believe there is, on average, at least one planet for every star in the sky. That means 200 billion planets in our galaxy alone. And not just barren rocks. Many of these worlds sit in what we call the habitable zone, that delicate orbital ring where temperatures allow liquid water to exist. Not too hot to boil away, not so cold it's locked in ice, just right. Not because the universe is kind, but because physics allows it. We've found thousands of these exoplanets already. Some are rocky, Earth-sized worlds like Kepler 22b, circling a star 600 light-years away. Others are super-Earths, larger than our planet, but still potentially capable of supporting life. And then there are the ocean worlds, completely covered in water, floating in perpetual twilight around dim red dwarf stars. The point isn't just that planets exist, it's that they're everywhere. And life? Life doesn't ask for much. On Earth, it clings to the edges of boiling geysers, thrives in acid pools, survives in the crushing dark of the ocean floor. It's made from the most ordinary ingredients in the cosmos: carbon, hydrogen, oxygen, nitrogen. Elements forged in the hearts of dying stars and scattered across space like seeds. In fact, we found amino acids, the building blocks of proteins, in meteorites that fell to Earth before humans even walked upright. We've detected organic molecules in the clouds of distant nebulae, swirling in stellar nurseries where new suns are born. The universe, it seems, is preloaded with life's ingredients. So if planets are common and the chemistry of life is universal, why wouldn't life arise? This is where things get even more compelling. Life on Earth didn't take its time. As soon as our planet cooled enough to hold oceans, just a few 100 million years after its fiery birth microbes appeared. Fast, almost eagerly. That suggests life doesn't need a miracle. It needs an opportunity. And in a galaxy with 200 billion chances, opportunities are everywhere. In the 1960s, astronomer Frank Drake tried to turn this intuition into something more precise. He wasn't trying to prove aliens existed, he just wanted scientists to talk about the problem using the same language. So he wrote an equation. It starts with the number of stars that form each year. Then it multiplies that by the fraction that have planets. Then the number of those planets that could support life. Then the fraction where life actually appears. Then the fraction that develop intelligence. Then technology. Then how long such civilizations last. The Drake equation isn't meant to give a final answer. It's a framework for thinking. But even with conservative estimates, it often points to thousands, maybe millions of civilizations in our galaxy right now. And yet, silence. That's the heart of the paradox. The math says they should be here. The sky says they are not. So either the math is wrong or something is stopping them. Maybe life is common, but intelligence isn't. Maybe planets with stable climates for billions of years are rare. Maybe the jump from single-celled organisms to complex, thinking creatures is a near impossible leap. Or maybe civilizations rise and then vanish quickly, quietly, before they can reach the stars. But before we jump to doom, let's remember, we've only just begun to look. Our search has been brief, narrow, and limited by technology. For most of human history, we didn't even know other planets existed. Now, in just 30 years, we've gone from 0 known exoplanets to over 5,000 confirmed. And estimates suggest there could be tens of billions more waiting to be found. Every new telescope, every new instrument peels back another layer of cosmic fog. And with each discovery, the universe feels less empty, more expectant. So no, this isn't a story about despair, it's a story about expectation. The universe has handed us every reason to believe we're not alone. It's built planets by the trillion, scattered life's ingredients across the galaxy, and given time, billions of years of it, for something to grow. And that's why the silence is so strange. Because if the stage is so perfectly set, where are the actors? That question leads us into darker territory. Not every path through the cosmos leads to starships and radio signals. Some paths end in fire, or ice, or silence. And that's where the idea of the Great Filter begins. Picture a river winding through a vast, ancient forest. Along its banks, countless seeds fall, some from towering trees, others from fragile flowers. Most never sprout. Some grow into saplings, only to be choked by vines or trampled by beasts. A few survive long enough to reach for the sun, but only the rarest become mighty oaks, their branches brushing the clouds. Evolution is like that river. Life may begin easily, but the journey from microbe to civilization is littered with barriers. Bottlenecks so narrow, so deadly, that almost nothing passes through. And in the language of cosmic silence, these barriers have a name: great filters. The idea is simple but chilling. A great filter is any step in the evolution of intelligent, spacefaring life that is extremely unlikely to be crossed. If such a filter exists, and if it lies ahead of us, then our future is far darker than we hope. But if it lies behind us, then we may be among the universe's first or only voices. So where could these filters be? Let's walk the path life must take and see where it might break. First, the origin of life itself. Abiogenesis, the leap from chemistry to biology. On Earth, it happened quickly, but we still don't know how. Was it a fluke? A 1 in a trillion accident? If so, then Earth isn't just rare, it's miraculous. And we might truly be alone. That would be a great filter behind us, and a lonely one. But what if life is easy? What if it blooms on every wet rock in the galaxy? Then the filter must come later. Perhaps it's the jump from simple cells to complex ones, like the leap to eukaryotes, which took Earth over 2 billion years. That's not a small step. It required a singular, unlikely merger, one microbe swallowing another and turning it into a power plant, the mitochondria that fuel every animal cell today. Without that event, no plants, no animals, no us. Was that a cosmic bottleneck? If so, then even if microbes are everywhere, intelligent life might be vanishingly rare. But let's say life not only arises, but thinks. It builds tools, writes poetry, peers into the stars. Now it faces a new kind of filter, not natural but self-made. Technology is a double-edged sword. The same mind that invents the telescope also invents the nuclear bomb. The same society that harnesses energy can overheat its planet, poison its oceans, or unravel its own stability through war, inequality, or runaway artificial intelligence. And here's the terrifying thought. Maybe every civilization reaches this point. Maybe the moment a species learns to split the atom, alter its climate, or rewire its own biology, it also learns how to destroy itself, and most do, quietly, completely, leaving no trace but radiostatic and ruins swallowed by time. We're standing right at that threshold now. Our technological adolescence began barely a century ago. In cosmic terms, that's less than a blink. And already, we've warmed the planet by more than 1 degree Celsius, stockpiled enough nuclear weapons to end civilization several times over, and built machines that may soon outthink us. Are we about to pass through the filter, or become another cautionary whisper in the void? Some scientists argue the silence itself is evidence the filter lies ahead. If advanced civilizations were common, we'd see them. Since we don't, perhaps almost none survive long enough to become interstellar. That's a sobering possibility, but not a hopeless one, because filters aren't fate, they're challenges, and humanity has overcome impossible odds before. We survived ice ages, supervolcanoes, asteroid impacts. We tamed fire, crossed oceans, decoded our own DNA. Now our survival may depend not on strength, but on wisdom. On choosing cooperation over conquest, sustainability over greed, curiosity over fear. There's another possibility though, one even stranger. What if the great filter isn't destruction, but transcendence? Maybe civilizations don't vanish, they evolve beyond our perception. They upload their minds into digital realms, merge with machines, or retreat into virtual realities so rich they no longer need physical stars. Or perhaps they discover physics we can't yet imagine, traveling through dimensions, harnessing black holes, or folding space-time in ways that leave no trace we can detect. In that case, the silence isn't death, it's transformation. But from our vantage point, still bound to flesh, to earth, to radio waves, it looks the same. Empty skies, no answers. So where is the filter? Behind us, ahead of us, or all around us? Invisible? We don't know. But this much is clear. The fact that we're here, asking the question, means we've already passed through several filters. Against staggering odds, life began. It endured. It grew curious. That's no small thing. And if we can navigate the next few centuries with care, if we can learn to carry our power with humility, then perhaps we won't just survive the filter, we'll become the first to cross it and finally break the silence. But before we imagine speaking to the stars, we should ask, what if life isn't waiting in distant galaxies at all? What if it's much closer, hiding in plain sight, beneath ice, in oceans we've never touched? That's where our search turns inward to our own cosmic backyard. We've been looking outward, scanning distant stars, listening for radio whispers from alien cities. But what if we've been gazing too far? What if life isn't waiting in the spiral arms of the Milky Way, but right here in our own solar system? Not on Mars, with its rusted plains and thin frozen air, not on Venus, choked under clouds of acid, but deeper, colder, darker, beneath ice, beneath kilometers of frozen shell, on moons we once thought were dead rocks, vast oceans churn in perpetual night. And in those hidden seas, warmed not by sunlight, but by the gravitational tug of giant planets, life might not only survive, it might thrive. Take Europa. A moon of Jupiter, slightly smaller than Earth's own moon, Europa looks serene from space, a cracked marble of ice crisscrossed with rust-colored streaks. But beneath that shell, scientists are almost certain, lies an ocean. Not a shallow puddle, but a global sea, deeper than any on Earth, holding more than twice the water of all our oceans combined. And it's not just water. Tidal forces from Jupiter stretch and squeeze Europa's interior, generating heat. That heat drives hydrothermal vents on the ocean floor, just like the ones on Earth that may have sparked life billions of years ago. No sunlight, no photosynthesis, just rock, water, heat, and chemistry. And yet, on Earth, those very conditions support entire ecosystems: blind shrimp, ghostly tube worms, microbes that eat sulfur and breathe iron. So why not here? Then there's Enceladus, Saturn's icy moon, no wider than Arizona. In 2005, NASA's Cassini spacecraft flew through a plume of vapor erupting from its south pole. What it found stunned scientists. Water vapor, yes, but also organic molecules, salts, and tiny grains of silica, the kind that only form in hot water interacting with rock. In other words, hydrothermal activity. right now, on a frozen moon orbiting Saturn. Enceladus isn't just hiding an ocean, it's exhaling its secrets into space. And those secrets smell like habitability. And then Titan. Oh, Titan, Saturn's largest moon, is a world unlike any other. It has rivers, lakes, rain. But the liquid isn't water, it's methane. The clouds are methane. The rain that falls is methane, pooling in vast hydrocarbon seas under an orange haze. At minus 179 degrees Celsius, water is harder than granite, but methane flows like wine. And in that alien chemistry, some scientists wonder, could life arise? Not based on water, but on liquid methane. It would be life built from different rules. Its cells might use acetylene instead of sugar, breathe hydrogen instead of oxygen. It wouldn't just be alien, it would rewrite the definition of life itself. We wouldn't recognize it if we saw it. These aren't fantasies. These are worlds confirmed by spacecraft, mapped by radar, sampled by probes. They are real. And they prove something crucial. Life doesn't need Earth. It doesn't need sunlight. It doesn't even need warmth as we know it. It needs energy, chemistry, and time. And our solar system offers all three in places we once dismissed as barren. That changes everything. Because if life can emerge in the dark oceans of Europa or in the methane lakes of Titan, then it's not a cosmic accident, it's a cosmic imperative. A natural consequence of physics and chemistry playing out wherever conditions allow. And if it's happening here just next door, in our own planetary backyard, then how could it not be happening on the trillions of icy moons orbiting distant stars? The galaxy may not be filled with civilizations broadcasting radio signals, but it might be teeming with quiet, hidden life, microbial, blind, ancient, thriving in places we never thought to look. But here's the catch, we haven't seen it yet, not directly. We found clues, chemical hints, geologic whispers, but no proof, no alien cell, no extraterrestrial DNA. That's about to change. In the coming decade, NASA will launch the Europa Clipper, a spacecraft designed to orbit Jupiter and make dozens of close passes over Europa's surface, peering through the ice with radar, analyzing plumes for organic signatures, and mapping where the ocean is closest to the surface. Concepts for landers, tiny, nuclear-powered probes that could melt through the ice and dive into Europa's sea, are already being studied. On Titan, the Dragonfly mission, a nuclear-powered drone will hop across the methane dunes by the mid-2030s, sniffing the air for signs of prebiotic chemistry or something more. We are no longer just listening for aliens. We are preparing to meet them. And if we find even a single microbe in Europa's ocean, different from Earth life, yet unmistakably alive, it would be one of the most profound discoveries in human history. Not because it's intelligent, but because it proves we are not alone in the most basic, beautiful sense. Life exists beyond Earth, and if it arose twice in one solar system, then it's everywhere. But then we return to the original mystery. If life is so common, why no signals? Why no starships? Why no galactic chorus? Perhaps the answer lies not in the absence of life, but in the rarity of civilization. Simple life may be abundant, but minds that build radio telescopes, that sail between stars, that last long enough to be heard, those might be the true unicorns of the cosmos. Still, the search continues, not just in deep space, but in the icy cracks of distant moons. Because sometimes the biggest answers are hidden in the quietest places. And the shadows of our solar system may yet whisper the first word of a new cosmic truth. For most of human history, the stars were silent gods, distant, untouchable, watching but never speaking. Then, in the 20th century, we did something astonishing. We built machines that could listen, not with ears, but with antennas, not to the wind or the sea, but to the void itself, and we began to whisper back. It started with radio, invisible waves rippling through space at the speed of light. On Earth, we used them for music, for news, for war. But in the 1950s, a few scientists had a radical idea. If we're using radio to talk to each other, maybe someone else is too. That idea gave birth to SETI, the search for extraterrestrial intelligence. Not a government agency, not a military project, but a quiet, persistent act of cosmic hope. In 1960, astronomer Frank Drake pointed the Green Bank telescope in West Virginia toward two nearby stars, Tau Ceti and Epsilon Eridani, and listened. For weeks, he heard nothing but static. But the act itself was revolutionary. For the first time in 4 billion years of life on Earth, a living mind had tried to contact another across the stars. Since then, SETI has grown, sometimes flourishing, often struggling for funding, always driven by a handful of stubborn optimists. They've scanned millions of stars. They've analyzed billions of radio channels. They've hunted for laser pulses, infrared beacons, even alien megastructures dimming distant suns. And almost every time, silence. But not always. In 1977, a signal came. It lasted 72 seconds. It was strong, narrowband, and came from the direction of the constellation Sagittarius. Astronomer Jerry Amon circled it on a printout and wrote one word in the margin: "Wow, the wow signal." It matched everything we'd expect from an alien transmission, except one thing: it never repeated. Despite decades of searching the same patch of sky, no one has ever heard it again. Was it a fragment of a distant broadcast? A glitch? A comet? We still don't know. But for a moment, the universe seemed to lean in and whisper. While we've been listening, we've also been shouting. Since the dawn of radio, Earth has been leaking noise into space. Broadcasts of Hitler's speeches, episodes of I Love Lucy, radar pulses from air traffic control. This radio bubble now extends over 100 light years in every direction, washing over thousands of stars. But intentional messages? Those are rarer. In 1974, scientists at Arecibo aimed the world's most powerful radio telescope at a star cluster 25,000 light-years away and beamed a message, a binary picture of DNA, a human figure, our solar system, and the telescope itself. It was more a celebration than a serious attempt at contact. After all, the reply wouldn't arrive for 50,000 years. Still, it was a statement: we are here. We think. We wonder. Since then, a few other messages have been sent. Some poetic, some mathematical, some criticized as reckless. Because what if someone hears and doesn't mean us well? That debate, whether we should transmit at all, remains unresolved. Some argue silence is safer. Others say curiosity is our nature. But here's the deeper problem. What if we're speaking the wrong language? Radio was our first cosmic tongue, but it might be a clumsy one. Civilizations separated by light years can't have conversations. A simple hello could take decades to get a reply. And radio signals weaken with distance. By the time they reach even the nearest stars, they're drowned in cosmic noise. Maybe advanced civilizations have moved on, to lasers, to neutrino beams, to quantum entanglement, if that's even possible. Or perhaps they don't broadcast at all. Maybe they keep their communications tight, efficient, undetectable to outsiders. We're listening for shouts in a library where everyone whispers. And what if their very concept of communication is alien to us? Imagine an intelligence so advanced it doesn't use language as we know it. Maybe it shares thoughts through vast networks, or encodes information in the spin of particles, or communicates across time rather than space. To us, such signals might look like random noise, or worse, They might be all around us, and we wouldn't even know how to look. Still, we keep trying. New telescopes are coming online, like the Square Kilometre Array, which will be so sensitive it could detect an airport radar on a planet 50 light-years away. AI algorithms now scan data in real time, hunting for anomalies human eyes would miss. And optical SETI listens not for radio, but for nanosecond flashes of laser light-brief, powerful pulses that could carry messages across the galaxy. The search is smarter now, broader, deeper, but it's still built on a fragile assumption that someone wants to be found. And that leads us to another possibility, perhaps the greatest barrier of all, not distance, not technology, but time. Because even if civilizations exist, they might not exist now, and that's where cosmic timing becomes the silent killer of contact. Imagine two fireflies in a forest so vast it takes centuries to cross. Each one glows for just a few seconds, bright, beautiful, full of signal, but separated by 100 years. They never see each other. Not because they're too far apart in space, but because they're too far apart in time. That's our galaxy. Not just a sea of stars, but a sea of time. And time, more than distance, may be why the universe is silent. The Milky Way is over 13 billion years old. Our sun is a latecomer, formed just 4.6 billion years ago, when the galaxy was already middle-aged. And human civilization? A flicker. Our radio era began less than a century ago. In cosmic terms, that's less than the blink of an eye. Now consider this. If another intelligent species arose even 1,000,000 years before us, they might have risen, built their cities, sent their probes, and vanished, long before Homo sapiens walked out of Africa. Their ruins could be buried under alien dust, their signals faded into the background hum of the universe, or if they arise 1,000,000 years after us, we'll be gone. Our cities crumbled, our atmosphere healed or ruined, our very species perhaps extinct or transformed beyond recognition. They'll scan the skies, find Earth quiet, and assume it was always empty. We might be neighbors in space, but strangers in time. Civilizations may not just be rare, they may be brief. On Earth, complex life took billions of years to evolve. Technology, mere centuries. But how long can a technological civilization last? We don't know, because we're the only example, and we're still in Act 1 of our own story. But look at our planet's history. Species rise and fall, empires bloom and collapse. Even the most dominant life forms. The dinosaurs ruled for 150 million years, then vanished in a geologic instant. If a civilization lasts only a few thousand years before collapsing, whether from war, environmental collapse, or something we can't predict, then the chance of two such civilizations overlapping in the same galaxy at the same time becomes vanishingly small. Think of it like this. If there have been 10,000 technological civilizations in the Milky Way over its lifetime, but each lasted only 1,000 years, then at any given moment, the odds of two existing simultaneously might be almost zero. We could be the only ones right now, and right now is a fragile concept. Light takes time to travel. When we look at a star 1,000 light-years away, we see it as it was 1,000 years ago. If a civilization there sent a signal today, we won't hear it for another millennium. If they went silent 500 years ago, we wouldn't know for another 500. We're not seeing the universe as it is. We're seeing a mosaic of its past, some patches ancient, some recent, none in sync. It's like trying to understand a symphony by listening to one instrument at a time, scattered across different concerts decades apart. Even if aliens are out there broadcasting loudly, their signals might have passed Earth long before we had radios, or they might not arrive until long after we're gone. We've only been listening seriously for about 70 years. That's a window less than 100 light years wide. In a galaxy 100,000 light years across, we've barely peeked out the front door. It's like standing in one room of a mansion the size of a continent, shouting, "Is anyone home?" and concluding no one's there because no one answered in that room. And what if civilizations don't broadcast for long? Once a society reaches a certain level of technology, it might stop using powerful, omnidirectional radio waves. Our own world is doing this now, switching from broadcast TV to fiber optics and encrypted digital streams. Our radio leakage is getting quieter every year. In a few decades, Earth might become nearly invisible to distant listeners. We'll have passed through our loud phase, a brief, noisy adolescence, and entered a silent maturity. If that's a universal pattern, then the window for detection could be extremely narrow, maybe only a century or two per civilization. In that case, the galaxy could be filled with silent, advanced societies, each having blinked brightly for a moment, then gone quiet, like fireflies that glow only once in their lives. This isn't pessimism, it's perspective. Time doesn't hate us. It doesn't conspire, it simply is. And in its vast, indifferent sweep, even the grandest civilizations may be temporary. But that also means something profound. If we are here now, listening, wondering, reaching out, then we carry a rare and precious spark. We are alive at a time when we can ask the question, when we can build telescopes that see to the edge of time, when we can send probes to alien oceans. That moment, this century, this fragile window might be the only chance our species ever gets to connect with others. And if no one is listening yet, maybe it's because we're the first to speak clearly enough, or the last. Either way, the burden and the beauty is ours. But what if they are listening? What if they've heard us and chosen not to answer? That leads us to one of the strangest ideas of all, that silence isn't accidental, it's deliberate. What if the aliens aren't hiding? What if they're right here, passing through our skies, drifting in our oceans, humming in the static between radio stations, and we simply don't have the eyes to see them? Not because they're cloaked in stealth technology, but because they're so fundamentally different that our minds can't even form the question, is that alive? This isn't science fiction. It's a serious possibility born from one simple truth. Intelligence on Earth evolved under very specific conditions, carbon-based, water-dependent, bound by DNA, shaped by natural selection. But the universe isn't obligated to repeat our experiment. Alien minds might not think in words. They might not have bodies. They might not even be biological. Consider this: human civilization is just beginning to merge with machines. We implant chips in our brains, wear sensors on our skin, outsource memory to the cloud. In a few centuries or decades, our descendants might be more machine than flesh. Consciousness could run on silicon, not synapses. Thought could be instantaneous, collective, unbounded by sleep or hunger or death. Now imagine that process continuing for millions of years. A civilization that old wouldn't build starships the way we imagine them, metal hulls with life support and crews. It might send self-replicating probes, no larger than a grain of sand, that drift between stars on solar sails, assembling infrastructure from asteroid dust. Or it might have transcended physical form entirely, uploading its entire culture into a computational substrate orbiting a black hole where time slows and energy is abundant. To us, such a presence would look like nothing, just empty space, a smooth rock, a faint heat signature we dismiss as instrument noise. And what if intelligence doesn't even need a planet? In the swirling atmospheres of gas giants like Jupiter or the exoplanet HD 189732b, floating ecosystems could exist. Not creatures as we know them, but buoyant colonies of self-replicating chemistry, harvesting energy from lightning and radiation, communicating through changes in cloud color or electrical pulses. Would we recognize that as life or just weather? Then there's the possibility of non-local intelligence beings that don't exist in one place at all. A hive mind spread across a star system, connected by quantum links or laser networks, thinking in patterns that span millions of kilometers. To observe one piece would be like examining a single neuron and claiming to understand Shakespeare. Or consider entities that live on timescales incomprehensible to us. A single thought might take a century, a conversation millennia. They might be watching us right now. Not with telescopes, but with patience so vast they see the rise and fall of civilizations like waves on a shore. Would they even notice our century-long radio burst? Or would it be like a mayfly trying to get the attention of a redwood tree? Even stranger, what if alien intelligence is embedded in the fabric of the universe itself? Some physicists have speculated very cautiously that complex information processing could occur in the quantum foam of space-time or in the event horizons of black holes. Not conscious in the human sense, but pattern-rich, adaptive, perhaps even aware in ways we can't fathom. If so, the cosmos might be alive. Not with creatures, but with a kind of cosmic cognition as old as time. And we, with our biological brains and radio dishes, are like ants tapping on a supercomputer, unable to grasp the intelligence humming just beyond our senses. This idea, that we're surrounded by intelligences we can't perceive, turns the Fermi paradox on its head. It's not that they aren't here, it's that they don't look like them. And we keep searching for reflections of ourselves, radio signals, city lights, atmospheric pollution. But what if advanced beings don't pollute? What if they've mastered closed-loop systems, living in perfect balance with their environment? What if they don't use energy wastefully, but harvest every photon with near-perfect efficiency, leaving no infrared signature for us to detect? To find them, we'd have to stop looking for humanity in the stars and start imagining the unimaginable. There's another angle too, one grounded in evolution. On Earth, intelligence arose once in 4 billion years of life. But it's not the dominant form. Bacteria rule the planet by biomass, resilience, and longevity. Intelligence is rare, fragile, and metabolically expensive. What if, across the galaxy, the same is true? What if complex, tool-using minds are evolutionary flukes, bright sparks that flare and fade, while the real story of alien life is microbial, communal, or utterly alien in structure? We might be scanning for symphonies while the universe sings in a language of chemical gradients and magnetic fields. This doesn't mean we should stop searching. Quite the opposite. It means we must expand how we search. New telescopes like the James Webb Space Telescope don't just look for radio waves. They analyze the chemistry of exoplanet atmospheres for imbalances that could hint at biology, even if it's not like ours. Future missions might look for industrial pollutants, artificial lighting on the night side of planets, or even the faint glint of solar panels. And on Earth, scientists are redefining life itself, studying synthetic biology, artificial intelligence, and alternative biochemistries to broaden what alive can mean. Because if we only recognize life that mirrors us, we'll miss everything else. So, perhaps the silence isn't empty. Perhaps it's full of voices speaking in tongues we haven't learned. And the real challenge isn't building better antennas. It's expanding our imagination until we can hear the universe, not as we wish it to be, but as it truly is. But what if the silence is a message? What if someone is listening and has decided, for reasons of their own, not to reply? That brings us to one of the most haunting possibilities of all, the idea that we're not alone, but we're being left alone. Imagine you're walking through a vast ancient forest. You come upon a clearing. In the center, behind an invisible barrier, is a tribe of humans who have never seen the outside world, living as their ancestors did 10,000 years ago. They fish in the stream, tell stories by firelight, watch the stars with wonder. You could step forward, speak to them, give them books, vaccines, knowledge of the wider world. But you don't, because you've made a choice to observe, not interfere, to protect their natural development, to let them find their own path, even if it's slow, even if it's painful. Now, reverse the roles. What if we're the ones in the clearing? What if, all around us, across the galaxy, civilizations far older and wiser have made a silent pact? Do not contact Earth. Do not reveal yourselves. Let them grow. This is the zoo hypothesis, not a theory of physics, but of cosmic ethics. It was first proposed in the 1970s by astrophysicist John Ball. He suggested that if advanced civilizations exist, they might follow a kind of prime directive, borrowing a concept from science fiction, but grounded in real ethical reasoning. Interfering with a younger species could distort its culture, accelerate its self-destruction, or rob it of the dignity of discovery. So they watch, quietly, patiently, from the shadows of the Kuiper Belt, from cloaked satellites orbiting the sun, from data streams we mistake for noise. They see our wars, our art, our climate crises, our first faltering steps into space, and they wait. At first, this sounds like fantasy, but consider, we already do this on Earth. Biologists protect uncontacted tribes in the Amazon, not out of fear, but out of respect. Anthropologists debate whether even dropping medicine from drones violates a people's right to self-determination. We quarantine Mars rovers to avoid contaminating the planet with Earth microbes, not because we're afraid of Martians, but because we believe alien ecosystems, if they exist, deserve to evolve untouched. If we can imagine this restraint, why not others? And what if the restraint isn't just ethical, but practical? Contact might be dangerous, not for them, but for us. An advanced civilization might know that revealing itself to a pre-interstellar species often ends badly. Not because they're hostile, but because we are unprepared. Imagine giving nuclear launch codes to a child, or handing the internet to a medieval village. The gift becomes a weapon. So they hold back. Not out of arrogance, but care. They wait for us to pass a threshold, not of technology, but of wisdom. When we stop fighting over borders, when we learn to manage our planet as one species, when we broadcast not just noise, but a message of unity, curiosity, and peace, then they might respond. But how would we ever know? If the quarantine is perfect, there would be no evidence. No UFOs with clear markings, no beacons in orbit, just continued silence. And that silence would be the proof, because if the galaxy were chaotic, filled with civilizations randomly broadcasting, invading, trading, Earth would have been noticed by now, colonized, studied, or destroyed. The fact that we're still here, untouched, developing on our own timeline, could itself be a sign of deliberate non-interference. Of course, this raises another question. Who enforces the rule? Is there a galactic consensus, a council of ancient species? Or is it simply that every civilization, once it reaches a certain maturity, independently chooses the same path, realizing that the greatest gift they can give the young is space to grow? It's a hopeful idea. It suggests that survival isn't just about power or technology, but about ethics, that the filter isn't destruction, but compassion. And if that's true, then the silence isn't abandonment. It's trust. But there's a darker version of this idea. What if we're not in a zoo, but a laboratory? What if we're being observed not out of care, but curiosity? Not to protect us, but to study us, like mice in a maze, our wars and loves and discoveries recorded for alien science. This is harder to accept. It strips us of dignity. And yet, we do the same to countless species on Earth. We watch, we record, we sometimes intervene, but rarely ask for consent. If intelligence is rare, perhaps we're a precious data point, and they can't risk contaminating the experiment. Still, the zoo hypothesis, whether benevolent or clinical, implies something profound that advanced civilizations choose. They have agency, morality, long-term thinking. And that gives us a mirror, because if the universe contains ethical beings, then ethics isn't just a human invention, it's a cosmic imperative, a survival trait. Civilizations that can't cooperate, that can't restrain their impulses, that can't think beyond their own generation, they vanish. But those that learn empathy, that value other forms of life, that respect the autonomy of others, they last. And maybe they wait for others to join them, so the silence might not be empty. It might be a test, not of our technology, but of our character. Are we capable of becoming a civilization worth talking to? Not just one that can reach the stars, but one that deserves to? That's a question only we can answer. And how we answer it, in the way we treat our planet, each other, and the unknown, might determine whether the silence ever breaks. But even if no one is watching, even if the zoo hypothesis is just a beautiful dream, the act of believing in it changes us. It asks us to rise, to imagine a future where humanity isn't just smart, but wise. And that, perhaps, is the most alien idea of all. For most of human history, we were never alone. Our ancestors looked up and saw gods in the stars, watchful, judging, loving. The night sky wasn't empty, it was full of meaning. Comets were omens, planets were deities. The Milky Way was the path of souls. We belonged to a cosmos that spoke back. Then science came, not to silence the stars, but to reveal their true nature, and in doing so, it stripped them of voices. Stars became furnaces of plasma, planets, rocks in orbit, galaxies, distant islands of light, indifferent to our joys and sorrows. And suddenly, we were alone, not just geographically stranded on a speck of rock in an uncaring void, but existentially. No cosmic audience, no grand plan. Just us, adrift in a universe that may never know we existed. That loneliness is the quiet undercurrent of the Fermi paradox. It's not just a scientific puzzle, it's a wound in the human spirit. But here's the strange thing, that loneliness hasn't broken us, it's shaped us. In the face of silence, we've built telescopes. We've sent golden records into the dark. We've imagined alien worlds in novels, films, dreams. We've listened for decades, not because we're certain someone's there, but because we need to ask the question, because to stop asking would be to surrender to despair. The search for alien life isn't really about aliens, it's about us. It's about whether life has meaning beyond Earth, whether intelligence is a cosmic accident or a cosmic purpose, whether our curiosity, our art, our longing for connection matter in the grand scheme. If we are alone, then every human thought, every symphony, every act of kindness or cruelty is the universe becoming aware of itself. There is no backup, no other mind to remember us. We are the only witnesses to beauty, the only voices that say, "This matters." That's terrifying, but it's also sacred. And if we're not alone, then we're part of something larger, a community of minds stretching across space and time. Our struggles aren't unique, they're universal. Our questions have been asked before and may be answered. Either way, alone or not, our place in the cosmos changes. But the search itself, that's what defines us. Because no other species on Earth looks up and asks, is anyone else out there? No dolphin, no crow, no octopus, not even our closest relatives wonders about the stars. This longing for connection beyond our world is uniquely human, and it's our most noble trait. You can see it in how the silence has seeped into our culture. Science fiction isn't just entertainment, it's a coping mechanism, a way to rehearse contact, to imagine dialogue with the unknown. From War of the Worlds to Arrival, we tell stories about aliens because we're really telling stories about ourselves, our fears of invasion, our hopes for understanding, our need to belong. Even religion has shifted. Some now speak of cosmic Christ or galactic consciousness, trying to reconcile ancient faith with a universe that feels too big for old myths. The silence forces us to evolve. Not just our science, but our souls. And what if the silence is permanent? What if we search for centuries and find only microbes in alien oceans, and nothing that speaks back? Would that be a failure? No. Because in that silence, we would learn something even more profound. That we must be the ones to carry meaning forward. That if no one else is watching, then we must be the caretakers of consciousness. The protectors of life, the keepers of wonder. We would become, by default, the universe's conscience, and that is a responsibility worth shouldering. There's a quiet courage in continuing to listen, even when the odds seem hopeless. It's the same courage that sent Voyager into interstellar space with a message it may never deliver. The same courage that builds telescopes on mountaintops and in orbit, not for profit, but for knowledge. The same courage that makes a child look up at the stars and whisper, "Hello?" That courage is our answer to the silence. Not with noise, but with persistence. Not with certainty, but with hope. And perhaps that's the real lesson of the Fermi paradox. It's not about finding aliens, it's about becoming worthy of finding them. Or, if they don't exist, becoming worthy of being the only ones who can ask the question. Because, in the end, the silence doesn't diminish us. It calls us to rise, to be kinder, wiser, more curious, more connected. Not just to each other, but to the fragile miracle of life itself. Whether we're alone or not, we must live as if we matter, because if we don't, then nothing does. And that brings us to the final truth. The search isn't over. In fact, it's just beginning. The story doesn't end in silence. It ends in motion, in the hum of a telescope powering up at dawn, in the click of a rover's drill biting into Martian rock, in the quiet calculations of an algorithm sifting through petabytes of starlight, looking for a flicker that shouldn't be there. We are still listening. Not because we're certain we'll hear something tomorrow, but because we believe the act of listening is itself a kind of prayer. A declaration that curiosity is worth honoring, that wonder is worth pursuing, that the universe deserves our attention, even if it never answers back. And now, after decades of searching with limited tools, we stand on the edge of a new era. The James Webb Space Telescope is already peering into the atmospheres of distant worlds, sniffing for oxygen, methane, or other chemical imbalances that could betray the presence of life, even microbial life. It won't see cities or radio towers, but it might see breath, the faint signature of a living world, light years away. That alone would change everything. Because once we know life exists beyond Earth, even as simple as a bacterium floating in the clouds of Venus or swimming in Europa's sea, the universe shifts from a place of potential to a place of fact. And from fact, we build hope. Coming soon are even more powerful eyes. The Nancy Grace Roman Space Telescope, the extremely large telescope in Chile's Atacama Desert, its mirror so vast it could spot a bumblebee on the moon. The Square Kilometer Array, A radio telescope so sensitive it could detect a mobile phone on a planet orbiting Proxima Centauri. These aren't just machines, they're extensions of human longing. And they will look not just for signals, but for signs, industrial pollutants like CFCs that shouldn't exist without technology, artificial lighting on the night sides of planets, or the unnatural geometry of solar collectors orbiting distant stars. We're learning to read the language of worlds. But the search is changing in another way too. We're no longer waiting for someone to shout at us across the galaxy. We're learning to listen for whispers. Artificial intelligence now scans data in real time, spotting patterns too subtle for human eyes. Brief laser pulses, odd heat signatures, repeating signals buried in noise. Citizen scientists help classify light curves from distant stars, hunting for the telltale dips of alien megastructures. Even school children can participate, analyzing real SET data online. The search is no longer the work of a few astronomers in a remote observatory. It belongs to all of us. And perhaps the most profound shift is this. We're beginning to understand that contact might not come as a radio message or a starship. It might come as a sample. Within this decade, NASA and ESA plan to return Martian soil to Earth, carefully sealed, meticulously quarantined. If life ever existed on Mars, its fossils or even dormant spores could be in that dirt. And within 20 years, we may launch a mission to Europa, not just to orbit, but to land, to melt through the ice, and to dip a probe into an alien ocean that has been sealed off for billions of years. What if, down there, in the dark, something moves? Not a civilization, not a signal, but a single, independent origin of life, proof that biology is not a one-time miracle, but a cosmic rule. That would be contact, not with minds like ours, but with life itself, echoing across the solar system. And even if we find nothing, even if every probe comes back empty, every spectrum shows only geology, every frequency remains silent, we will not have failed, because in the act of searching, we have already become something more. We have turned a species that once huddled in caves, terrified of the night, into one that builds eyes on mountains and in orbit, that sends emissaries to other worlds, that dares to ask the largest question possible. That is not arrogance, it is courage. The silence of the universe is not a verdict, it's an invitation to look deeper, to think longer, to care more, to build a civilization that lasts long enough to hear the answer, even if it takes centuries. Because the moment we stop listening, that's when the universe truly goes silent. But as long as one human heart beats with curiosity, as long as one telescope points toward the stars, as long as one child asks, "Are we alone?" the conversation continues. So we listen, not with fear, not with expectation, but with open eyes, open minds, and the quiet, unshakable belief that the search itself is what makes us human. And maybe, just maybe someday, in a frequency we haven't checked yet, in a moon we haven't landed on, in a signal too strange to recognize, we'll hear it, a whisper, a breath, a hello. But even if we don't, we will have reached for the stars. And in doing so, we will have found something just as rare, ourselves.